All right, we're going to get started with Modern Arithmetic 4. Just get my book set up here. Raise Higher Arithmetic, which is the textbook for Modern Arithmetic 4. All right. So in this course, in this class, this is our third lesson in Higher Arithmetic 4. In the first lesson, we had an introduction to arithmetic and we studied articles 1 through 5. In the second lesson, we studied articles 6 through 22. And in this class, we're going to try to get from article 23 to article 39, which is the end of this first section. So let's get our notes ready. Modern Arithmetic 4. Modern Arithmetic 4. And we're studying articles 23 through 39. Hopefully we can get through all of that. This course, Modern Arithmetic 4, is intended to be studied by students who are in 8th grade and through high school to make sure that all of the concepts of arithmetic are really mastered. So it's my desire that a student who's studying Modern Arithmetic 4 would also be studying Algebra 1 at least. So a lot of this introductory material that's in these first few pages of the book is found both in Higher Arithmetic book and in the Algebra 1 book. So for those studying both courses, one or the other is going to be review. What I'd like to do is just pick up at Article 23 and go through to the end of this section, this introduction. You can see that in Article 23, as we look at the text here, in Article 23 we begin the study of the signs that are used in arithmetic. So a lot of this information should be review for those who have studied arithmetic already, but we want to make sure we pay attention to details, and most importantly, we want to make sure that we read the textbook definitions and rules carefully, because no matter what we've studied or what program we've studied or what book we've studied, in this book, these definitions and rules are going to be the norm. So we want to make sure that we learn what this textbook has to say, because we're establishing the language that we're going to use in this textbook. Jake, can you close that door up? So we're picking up on Article 23. The first definition that we have in Article 23 is a sign. A sign is a character used to show a relation among numbers, or that an operation is to be performed. So signs are used to signify two different things. Signs are used to signify a relation that exists between quantities, or to show that an operation is to be performed. So a sign is a character that's used to signify a relation among numbers or an operation that is to be performed. That's a sign. So what I want you to know is signs show two things, one of two things. A sign either shows that a relationship exists between two or more quantities, or the sign shows us that some mathematical operation is to be performed. Something is to be done. Then in Article 24, we see the most commonly used signs in arithmetic. We see these signs, and we want to make sure that as we go through this chapter, we learn what all of these signs mean. So we have some simple ones, like the plus sign, subtraction sign, multiplication sign, division sign, equal sign. These are all symbols or signs that we use to express different ideas. We also learn the radical sign. We'll talk about that in this lesson, the radical sign. We see this colon, and then we see a double colon. We'll talk about what that means in this lesson. We then see parentheses, and then we see a triangle of dots. And there are a couple other signs here in this book. We've got a beetle that wants to be on camera. We've got a couple other signs in this book that really aren't used much in modern arithmetic, especially today, which we'll learn about them, but we're not going to pay too much attention. But we see the signs that are used in arithmetic, and we want to make sure that we understand what these signs mean, because these signs are the language of arithmetic. Okay? Article 25, we start with the sign of addition. The sign of addition, so the first sign we learn is the sign of addition. The sign we know, the plus sign, and this sign is read. In other words, it's used to signify the idea or the word plus. It signifies an operation. So when we see 3 plus 5, it tells us that an operation is to be carried out. These two numbers are to be added together. So the plus sign is an example of a sign that shows that an operation is to be done. Something is to be done. Article 26, we move to the sign of subtraction, and I'm going to move quickly because this stuff should be known to students in this course. We're just going to concentrate on any specific points that are worth mentioning. The sign of subtraction, just a straight horizontal line. And this sign represents the word minus, which in Latin means less. And so if we read this as 5 minus 3. Simple stuff. The sign of subtraction. It's important for us to know, though, that addition can be written in any direction. It doesn't matter whether we write 3 plus 5 or 5 plus 3. But subtraction cannot be written in any direction. When we write a subtraction problem or an expression of subtraction, this first number is called the minuend. I'd like you to learn this. Minuend, in Latin, that means the number which is to be diminished. The number to be diminished. And the second number in a subtraction expression is called the subtrahend, which is Latin for the number to be taken away. The minuend is the quantity to be diminished. The subtrahend is the number to be taken away. A subtraction problem can only be written in this order. We can't change the order. It's important to know which quantity is the minuend and which quantity is the subtrahend. Just a simple point about subtraction, but one that we want to see is different from addition. Addition can be written in either direction and it has no effect on the outcome. Subtraction has to be written in this direction. The minuend followed by the minus sign followed by the subtrahend. That's the sign of subtraction. Article 27, the sign of multiplication. Article 27. The third sign we learn is the sign of multiplication. Which is a diagonal cross. The sign of multiplication, a diagonal cross. It's read multiplied by. That symbol represents the expression multiplied by, or times. Multiplied by is the better expression though. Multiplied by. So the expression for multiplication sign and 5, these two numbers are called factors. The numbers that we multiply are called factors. 4 multiplied by 5 equals 20. This number is called the product. The result of multiplication is called the product. The numbers multiplied are called factors. The result of multiplication is called a product. This expression is read 4 multiplied by 5, or 4 times 5. Multiplication is like addition. The numbers can be reversed and it makes no difference on the outcome. 4 multiplied by 5 equals 20. 2 factors and a product. If we flip it around and say 5 multiplied by 4, the product is the same. So the third sign is the multiplication sign. That's Article 27. All of these signs so far represent operations. Article 28 is the division sign. So the fourth sign we learn in this lesson is the division sign, another sign that shows an operation, and the sign is a horizontal line with a dot above and below it. It's read divided by. So if we have 20, then the division sign in 4 equals 20 divided by 4 equals, the answer is 5, and the names of these quantities have names. The first quantity in a division product is called a division problem. Is called a dividend. The dividend means the quantity to be divided. You better write these down. You need to learn these things. This is the language of mathematics. The dividend is the number to be divided. The number that divides is the divisor. Dividend, the number to be divided. Divisor, the number that divides, the divider. And then the answer to a division problem is called the quotient, because it tells us how many times the dividend can be divided by the divisor. Quotient, how many times. The dividend divided by the divisor equals the quotient. 20 divided by 4 equals 5. The sign of division, another sign of operation. The number to be divided always has to be on the left. The divisor is always on the right. So like subtraction, the order always has to be the same. You can't flip the quantities like addition or multiplication. That's Article 28. Article 29. We learned about the radical sign. Article 29. The radical sign looks like a check, but it contains a quantity inside of it. So I'll put 16 in here. The radical sign is this sign that looks like a check. In Article 29 of our textbook, we read, the radical sign indicates that some root is to be found. The radical sign indicates that some root is to be found. The word radical comes from the Latin word radix, which means root. So this isn't some kind of mystery. The radical sign is just the root sign. It's nothing fancy, nothing mysterious. The radical sign just means the sign that shows the root. What we mean by a root is a number, a quantity which multiplied by itself gives this product. So a root is a number. I'll write number since we're in arithmetic. A number which multiplied by itself gives the product. Gives the product under the radical sign. So what number multiplied by itself gives 16? What number multiplied by itself produces 16? 4. Okay? When we have the radical sign by itself, that's called the square root. We ask what number multiplied by itself gives this product. That's the square root. We could also use the radical sign with an added number there. And I'll put the number 8 inside here. This is called the square root. It asks what number multiplied together twice gives this product. This is called the cube root. It asks what number multiplied 3 times gives this quantity. The cube root of 8 is equal to 2. And that's how these are read. The square root of 16 equals 4. The cube root of 8 equals 2. Because 2 times 2 times 2, 2 taken 3 times, 2 taken 3 times equals 8. 2 is taken 3 times, and that's what that number signifies. This little number here, where can I write it? I'll write it down here. This little number written above the radical sign, anybody remember what it's called? Index. So the radical sign asks for a root. Again, it shows an operation. Find the square root of 16. Find the cube root of 8. The radical sign is Article 29. The radical sign indicates that some root is to be found. Thus, the square root of 36 is shown there. The cube root of 125 is shown in the text, and the fourth root of 625. So one of the examples in the book is the fourth root of 625. And the answer to that is 5, because 5 times 5 is 25, times 5 is 125, times 5 is 625. 5 multiplied by itself 4 times produces 625. This is called the fourth root. This is the third root or cube root. This is the second root or square root. But what's important in this lesson is the meaning of the radical sign. Okay, that's Article 29. Article 30 just summarizes and tells us that the plus sign, the minus sign, the multiplication sign, the division sign, and the radical sign are symbols of operations, which I've already said. Those signs, those first 5 signs, are signs of operations. In Article 31, we learn about the equal sign. So this is the 6th sign, the equal sign. And as much as everyone will say, oh, that's so easy, the concept of equality is one of the most important concepts in mathematics. And often, students can't understand concepts in mathematics because they really don't understand the importance of equality. When we say that one quantity is equal to another, that means they're interchangeable. They represent the same quantity in mathematics. The equal sign is represented by 2 horizontal lines. It does not signify operation, but it shows that a relation exists between 2 quantities. The equal sign is a sign of relation. So if I say 5 plus 3 equals 8, you get used to this in elementary arithmetic classes. But what this is telling me is this expression, 5 plus 3, and the number 8 are equal. They can be used interchangeably. And if I have another expression that tells me 4 plus 4 equals 8, logic tells me that 5 plus 3, 5 plus 3, based on these 2 expressions, 5 plus 3 is equal to 4 plus 4. So equality tells us that quantities can be interchanged because they have the same value. They represent the same quantity. The equal sign. That's the 6th sign we've studied, and it's the first sign of relation. When we have an expression that tells us that 2 quantities are equal, this expression here has a name. It's called an equation. An equation, another very important concept in mathematics, equation. Anytime you hear the word equation, it means that we have shown that 2 quantities or more quantities are equal to each other. So if I were to use, again, Einstein's famous formula, this E equals mc squared, this is an equation. This is an equation. If I were to give the formula for finding the speed of a moving object, and if I said the speed was equal to the distance divided by the time, This is an equation. I'm showing you that two different quantities are equal. Take notes and pay attention. I'm showing you that these two quantities are equal. This expression is called an equation in mathematics. Again, this is the language and vocabulary of mathematics. This is the kind of stuff, for all the complaining about mathematics that kids do, for all the fussing, say, I don't understand math, this is the kind of information, these are the lessons that cause students to not understand math. And there's no excuse, because modern math, for all the attention it gets, for all the fuss people make about modern math is simple. Modern math is easy. Translation work, grammar, reasoning, philosophy, that stuff is hard. Modern mathematics is easy. The problem is students don't pay attention to the lessons on vocabulary, definitions, rules. This is not complicated work. This is not the kind of study or work that requires great mental labor. All you have to do is learn the definitions, learn what the signs mean, and then just follow the instructions. This is not the kind of work that brilliant people do. Modern mathematics is not difficult. So if you're going to struggle in mathematics, it's because when we're studying the definitions, the signs, the rules, this basic information, you're not paying attention. And then we're going to have to listen to you talk about how you think math is hard and algebra is hard. They're not hard subjects. That's why they're in public schools. If they were hard subjects, they wouldn't be in public schools. Philosophy and metaphysics, they're not in public schools because they're hard subjects. Modern mathematics is not a hard subject. This is where you learn the language of mathematics, and if you don't learn it, it's like not learning Spanish and then traveling to Spain and complaining that you can't understand anything. It's your fault. This is the language of mathematics. So we learned what an equation is. An equation is an expression that shows us that two quantities are equal to each other. That's an equation, and that's found in Article 31. All right? Article 31, the equal sign and the definition of an equation, which is a term that you're going to see over and over and over again in mathematics. The seventh sign that we learn, the seventh sign in Article 32 is a sign of ratio. Ratio. Oops. Ratio. A ratio is a relationship. Obviously, it's a sign of relation. It's a relationship between quantities, a ratio. To express a ratio, we use these two dots. The textbook reads, ratio is the relation which one number bears to another number of the same kind. Ratio is the relation which one number bears to another number of the same kind. The sign of the ratio is what we call a colon, one dot above the other. The sign of ratio. Ratio is expressed thus. So a ratio is written like this. And this sign is read is to. 6 is to 3. 6 is to 3. Which expresses the same relationship as a fraction, 6 over 3, 6 divided by 3. This expresses the relationship of 6 and 3, and we find that the ratio is equal to 2. The ratio 6 to 3 is the same as 2 because 2 is the same as 2 to 1. The ratio of 6 to 3 is the same as the ratio of 2 to 1 because 6 is twice 3. Six to 3 is equal to 2 to 1. The ratio 6 to 3 is equal to the ratio of 2 to 1. 2 to 1 is the same thing as saying 2. Because a number is always a ratio. Every number is a ratio. Every whole number is a ratio where the number is related to 1. 2 is the same thing as 2 to 1. The number 6 is the same thing as the ratio of 6 to 1. But these two dots show that there's a ratio. The relationship between 6 and 3, 6 is to 3, that ratio is equal to 2 to 1, which is equal to 2. The relationship between these two numbers is the same as the relationship between 2 and 1. In Article 38, we learn this next sign, which is the sign of proportion. Another sign of relation. It's this sign made of 4 dots. The sign of proportion. This is Article 33. Proportion is an equality of ratios. And this is where, if you're not paying attention, you're going to get lost because we're starting to take ideas and build on them. If you didn't pay attention to this idea, we're going to build on it in this idea, and you're going to get lost. Proportion is an equality of ratios. These 4 dots, this sign here is called the sign of proportion. It expresses an equality of ratios. So this is like the equal sign, but this is like an equal sign between 2 ratios. All right? The sign of proportion. And I've already given you an example of this because when we have a comparison of ratios, I use the equal sign here just to show you that this proportion or this ratio is equal to this. But we wouldn't use an equal sign. We wouldn't use an equal sign to show the equality of two ratios. We don't use the equal sign to show that 2 ratios are equal. We use the sign of proportion. Six is to 3 just as 2 is to 1. You see that? 6 is to 3 just as 2 is to 1. And you'll see these symbols even in language arts. You could see them on the SAT test or on a standardized test. You'll see something like this. Father is to son as mother is to blank. Okay, you'll see these problems in standardized tests are called analogies. Okay? What would the answer be? Father is to son as mother is to daughter. Okay? So if you ever see this in a standardized test, it's called an analogy. It's a popular type of question. But you see the symbols, they come from the symbols of ratio and proportion in arithmetic. Okay? That's what these things mean. So the 2 dots is a symbol of ratio. The 4 dots is a symbol of proportion. Proportion is an equality between ratios. Do you understand that idea? All right, so let's look at an example. Let's try one. So if I have the proportion of the ratio 14:7 as blank is to 5. What number will make this proportion true? 14:7, just as this quantity is to 5. What is that quantity? Right, 10. The relationship between 14 and 7 is that 14 is twice 7. So the answer that's missing in this ratio is that number which is twice 5. 10 is twice 5. And you see how we express it with these symbols? 14:7, just as blank is to 5. That's ratio and proportion. Let's try another one. I'll flip this around. 9 is to 45, just as 7 is to blank. What's the missing quantity there? 35. Okay, so 9 is to 45. The relationship, the ratio of 9 to 45 is 1 to 5. 45 is 5 times 9. So if we're going to write an equal ratio that has the same proportion as 9 to 45, but we're going to have 7 be the first quantity, the missing number to complete this ratio will be 5 times 7, which is 35. The 2 dots are called the sign of ratio. The 4 dots are called the sign of proportion. A proportion is an equality between 2 ratios. You understand that? Okay? It's just signs. It's just basically translation work. Proportion is a sign of an equality of ratios. Article 34. We're getting into some things where some of the symbols aren't really used anymore. You have a question? Oh. Article 34, we're taught the signs of parentheses. We're told in Article 34, the signs of the parentheses and the vinculum, that's what the straight line is called. These are called signs of aggregation. Signs of aggregation. I'll put this word up on the board. Signs of aggregation. Two signs of aggregation are the parentheses and the vinculum. This is called the vinculum. Signs of aggregation. The first is the parenthesis, the second is the vinculum. I already said that. They are used for the same purpose. They do the same thing. But in modern math classes, modern math textbooks, the parentheses are always used. I don't believe that the vinculum is used. So if we had an expression like this, 24 minus 8 plus 7 equals blank. What this shows us is that these two quantities are to be taken together. 24 minus, in parentheses, 8 plus 7 equals blank. What we should do, if we see that, is find this sum first, because it's set in parentheses. So we would say 24 minus the sum of 8 and 7, which is what? sum of 8 and 7. Okay, and then find the solution, find the answer, 9. But you see how we solved what was inside the parenthesis first? Okay? The parenthesis shows us that this is to be treated as a separate quantity. And this is going to be very important in algebra. And some problems, this actually changes the outcome of the question. Ready? Let's say we're going to ignore the parentheses, right? Let's say we're going to ignore the parentheses. Watch what happens. You saw how we did 24 minus 15 equals 9, right? Watch what happens if we ignore the parentheses. What's 24 minus 8? 24 minus 8, 16. 24 minus 8 is 16 plus 7. 16 plus 7. 16 plus 7, 23. Look at the two answers. This one, we treated this as a separate quantity inside the parentheses. The answer was 9. This one, we ignored the parentheses and got the wrong answer. Because the parentheses shows us that this together is one quantity. We're not subtracting 8 and adding 7. We're subtracting 15. So you see the difference? Okay? The parenthesis changes the outcome of that expression. So that's all for Article 34. The numbers inside the parenthesis are considered as one quantity, so they're always to be treated separately first. These dots in our lesson, one of the symbols is 4 dots. They're called leaders, and all that they're used to do is show us that something continues. Okay, dot, dot, dot. You see that in language all the time. Article 36, the sign of deduction. What in the world? The sign of deduction. These 3 dots that look like a triangle of dots are called the sign of deduction. They mark that a conclusion is being drawn from what has been said before. The sign of deduction is read therefore. It gives some other possible translations of the sign, but you just need to learn therefore. Okay? These 3 dots, the sign of deduction, means therefore. So just to give you an example from reasoning, if I said all men are rational, Socrates is a man, and I wanted to write the conclusion based on those 2 propositions. Before I write the conclusion, I would use the sign of deduction, and that means therefore. Do you understand that? Do you follow me here? That sign is translated as therefore. Therefore, Socrates is rational. I'm making a conclusion. I'm drawing a conclusion. This is the sign of deduction. I'm reasoning to a conclusion. Those 3 dots are a sign of deduction. That's Article 36. Article 37 just summarizes those 4 or 5 articles and says the signs, the equal sign, the sign of ratio, the sign of proportion, parentheses, the vinculum, the dots, which are called leaders, and the sign of deduction are called symbols of relation. They show relationships. The All right, the last two articles wrap up this introduction. Article 38 says, arithmetic depends on this primary proposition. Arithmetic depends on this primary proposition. Any number may be increased or diminished. Any number may be increased or diminished. Arithmetic depends on this primary proposition, or the assumption that all arithmetic is based on is the assumption that any quantity may be increased or diminished. This is an axiom because it's the definition of a quantity, that a quantity is a thing that can be increased or diminished. So this is the primary proposition. You should take the time to write this out and think about it. The primary proposition, or the axiom on which all arithmetic is based. The primary proposition of arithmetic, based on the definition of a quantity, is that any quantity may be increased or diminished. And that goes on in all directions for infinity. Any quantity may be increased or diminished, and that's based on the definition of a quantity. That's what makes a quantity a quantity. A quantity is anything that may be increased or diminished. Therefore, we may assume that any quantity, by being a quantity, may be increased or diminished. Addition, multiplication, and involution. So increasing quantities, we practice this by the operations of addition, multiplication, and involution. And we'll see how well you paid attention to our algebra lesson to know if you know what involution means. You should. And diminishing quantities we do in subtraction, division, and evolution. Addition, obviously adding one quantity to another. Multiplication, multiplying one quantity by another. Both of those cause increase. Involution means powers, multiplying numbers by themselves. To diminish quantities, we can subtract, we can divide, or we can perform the operation of evolution, which means to find roots. Okay? Involution and evolution. So we have three operations by which quantities are increased, three operations by which quantities are diminished. We can assume that any quantity can be increased or diminished because it's a quantity, and that's what a quantity is. If something can't be increased or diminished, then it's no longer a quantity. Mathematics is the science of quantity. If something can't be increased or diminished, then it's not a quantity and it's not a part of mathematics. And lastly, Article 39, this is the last article of this introduction. It says the fundamental operations of arithmetic are numeration, that means counting, right? Numeration. Notation, That means writing numbers, expressing numbers. Addition, subtraction, multiplication, and division. So there are 6 fundamental operations in arithmetic. 6 fundamental operations. Numeration and notation, or we should say 5. Numeration and notation, let's consider them as one together. Numeration and notation, addition, subtraction, multiplication, and division. 5 fundamental operations of arithmetic. And that brings us to the end of the introduction. All right, so in this third class, we've finished all of the content of the introduction. And in our next lesson, we're going to move forward with the real beginning of this study of higher arithmetic in Modern Arithmetic 4. So what I'd like you to do to finish this class is take a few minutes. Don't try to quit early. Take a few minutes, write out a brief summary of what we talked about in this lesson. And that will be all for this third lesson in Modern Arithmetic 4.